Are most of the people interested in heat pumps that you talk to? Is it for like environmental reasons?
I see a lot more solar panels over the last 10 years.
In California, people are doing it just because they have power outages.
I've seen over 12 years that properly sized HVAC systems, even single stage systems here in Houston, typically are going to land that room between 55 and 65% relative humidity.
Are you talking about like blackouts or brownouts? And is it mostly in the summer?
There's two products that I'm a huge fan of.
What are some of the IAQ products that you guys like to use, and how effective are they improving the quality of air in people's homes?
I've seen statistics that 65% of the homes' electrical usage during the summer is their cooling.
What is actual life expectancy down there for the systems you guys are replacing?
If you're looking to go energy dependent, that's definitely the route to go.
Our climate is actually fit pretty well for heat pumps.
We don't have a lot of straight cool with electric heat, but for the people that do have that, they definitely should be installing the heat pump.
If you're putting in a media filter, are you having to change that twice a year out there?
We recommend you change it at least once a year.
What brands do you guys carry? Hello and welcome to the show. In today's video, we have a special guest. We have Seth Mapp with us. He is the founder of, or the owner of Airecon, and now the GM of Champion and Nash. They serve the greater Houston area all the way from Galveston up to Conroe, Texas. And we're going to be talking about a variety of topics. We're going to be talking about humidity control, system sizing, some of the issues that they face on a regular basis when it comes to residential HVAC and humid Houston, Texas, which is one of the most demanding HVAC clients. So please help me welcoming to the show, Seth Mapp. Seth, how's it going?
Oh, it's going great. How are you today, Howard?
Doing good. So thanks for coming on the show. Obviously, you've watched the show a little bit and seen kind of what we talk about here. This is primarily a channel that educates consumers on how to get the best HVAC for their home. So that being said, just to kind of dive in, tell people a little bit about background on HVAC in the Houston Metro and kind of some of the issues that you guys run into on a daily basis and how, people can get the best HVAC for their home.
Yeah. Well, I mean, you've nailed it. I mean, Houston is a extremely demanding environment for HVAC systems. The humidity, the temperatures that we have every summer. Well, we always joke, we have 2 weeks of winter, the rest of the year summer, right? So
yeah, exactly.
I had actually seen one time that Houston wouldn't be habitable if it hadn't been for the invention of air conditioning. just because it's so bad here. What we found though, so I've been in the industry for 12 years, came from a different industry, working in the petrochemical sector. When I joined the industry, I knew nothing about air conditioning. So I got to learn from the ground up, starting installing, running service calls, all the good stuff that goes into it. What we found was that the more we came to really understand how systems are designed to use the laws of thermodynamics to remove energy from a home and dump it outside, is that a lot of the systems down here are not correctly sized for the environment that they're in. And there was a misconception, I believe, that it was like putting bigger engines in a car. Like if you want to go faster, put a bigger air conditioner in. And so a lot of times over the years, one generation, 2 generations of homeowners, in that home would start upsizing the systems. And next thing you know, a home that should have had a 3-ton system has a 5-ton. So as we started really getting into the science, using manual J, for instance, to correctly size systems, we started downsizing those systems, taking the 5-ton out, putting 3 tons back in, which actually tremendously helps dehumidification for a number of reasons.
Now, I imagine a lot of people watching this, especially in Houston. I actually lived in Sugar Land for a year of my life, so I know what it's like to deal with that humidity. You step outside and it punches you in the face. I mean, it is a very hot, humid climate. And like you said, air conditioning is a lifeline. It can be nerve-wracking thinking, wait, I'm going down in sizing. Explain what would cause people to increase their size in the first place. Like if they're replacing their air conditioning, is it the thought that, like you said, bigger is better, or is it humidity removal, or what is the primary concern that people are like trying to address with that bigger system? And what's the right way to address the actual issue?
Yeah, I think for a lot of people, there are just systemic problems in their home that lead to maybe not being as comfortable as it should be. Things like infiltration or just their lifestyle, perhaps. And so the thought, I think, would be if I put a bigger system in, it's going to get to the temperature I want it to be at faster and perhaps not use as much energy to do so, which is a misconception as well.
Because
But I think that's
it's
where,
actually using more power, right? Because it's short cycling and actually working harder. And that
right.
bigger and that when you were saying lifestyle, can you just clarify what do you mean by lifestyle? What lifestyle would be
Yeah,
not
so
conducive?
lifestyle, choices definitely affect the heating and cooling of a home. So every single human body puts off heat, right? So if you have a large party, a lot of people come over. We've all
Got it.
experienced it around the holidays.
Yeah.
The up going, you got 20 people in the house, and your system seems to not keep up, gets hot, or it just doesn't feel comfortable. Those are some of the lifestyle questions that we actually go into with clients of ours when they're looking to replace their HVAC system. We've had people that through large parties all the time, and so that they may need a different sizing equation than someone who's just mom and dad and live at home.
Wow. Okay, that's interesting. So if someone's throwing a bunch of ragers, you got to increase the ductwork to satisfy the
Yeah,
body count. Yeah,
yeah.
good
I
to
mean,
know.
if they're doing it too much, we're not having to look at air change out. And, no.
Yeah, that's
Stuff.
crazy.
But,
That's yeah, no, that's funny. No, it just reminds me of thinking because I know that comes into play obviously in commercial buildings because body count is obviously you go into a big commercial venue, for example, if there's 1,000 people in there, that's going to change the load on the space versus 10 people and just having it be empty, right? Yeah, but I haven't heard it mentioned as much in residential, so that's interesting. But yeah, I was just curious what you meant by lifestyle choices because I hadn't heard that mentioned on the channel before. So
well, even there are a lot of consumers that will have aquariums in their homes or a lot of pets. It's just how people live their life. We had one client, he had vintage guitars, he collected guitars.
gotcha.
And obviously, musical instruments are very susceptible to warping and damage from humidity levels. Too low is bad and too high is bad.
Yeah.
So it was very important for him that we were able to design the system that kept his house within that 45 to 55% relative humidity zone that he needed for his guitar collection. And so those are really fun for us because it's something a little unique. It's something that we may not run into every day. It gives us a new challenge to overcome.
Yeah, absolutely. No, in Colorado, we definitely run into the opposite problem, but we'll get, pianos out here or guitars, same thing, because the soundboards will crack because our relative humidity hits, 17% in the winter, which the Sahara is 22, which is a fun fact. It's always drier than the Sahara. But, and so I always think that's interesting, but the ideal temperature or humidity is 41% for those, or 41.6 for the grand pianos. And so we'll normally try and get them to 35 or 40, because otherwise you start at 40, a lot of times you'll get condensation and stuff on the windows because of the relative humidity as it relates to the outside. So, and you don't want, water pooling and dripping down the walls because that could be a problem. And so no, that's interesting. So when you're dealing with a customer that's looking for, obviously a system like that or humidity removal, I learn a lot from this channel. Sometimes I'll get questions in the comments that I've never heard before. It's one of my favorite things about running it is I'm always getting, challenged and there's new questions. One question we had one time was about inverter systems and how they relate to humidity removal because they had an inverter system installed and it wasn't doing as good of a job with humidity removal. And he was trying to get a referral. It was in Texas. I believe it was in Dallas, if I'm not mistaken. And what are some of the considerations for someone because a lot of people watching this channel, that's what they're looking for. They're looking for inverter driven heat pumps or high efficiency heat pumps, and they really want a contractor that's familiar with those. Where do things go wrong in your climate when it comes to an inverter that maybe isn't keeping up for humidity removal? Is it, too big, too small, ductwork? What goes into that?
Yeah, that's a great question because just putting the system in doesn't necessarily mean it's going to perform to its optimal, manufacturer design. So what we do, if we were looking at doing an inverter system, number one, they're exceptional because all air conditioning has some component of dehumidification, right? That's just what happens when you cool air down. It condensates water out of the airstream. What inverters allow you to do is take that down to almost freezing. Like you can get it much colder, much longer without the danger of the system icing up and potentially damaging components by modulating the fan inside and the compressor outside. So what we like to do is number one, we have to know that we have the right CFM, right? We have to have enough return. We have to have enough supply. We actually would go in and do a room by room heat load with some really cool tech that we have that allows us to do it very quickly.
And CFM, just for like people that aren't familiar, that's cubic feet per minute, right? And so that's, and you're sizing CFM based on the size of the space as well as for the ductwork, correct?
Right, correct. So if we were designing a duct system, or if we were going in and retrofitting a home to put an inverter in, we would want to go through and make sure we have enough supply and return from each of the spaces in the home, especially, bedrooms where doors will be closed at night. If they don't have a dedicated return, the air is going to kind of get stuffy in there. We want to make sure that home's breathing well, that we have the correctly sized ducting, that the ducting is laid out appropriately for maximizing the system's performance. And then the next thing we would do is correctly size the system based off of a manual J. There was a misconception early on with the kind of inverter, variable speed inverter driven systems that you didn't have to worry about sizing as much because you could just dial it into the home. That's not the case. They still need to be properly sized in accordance with manual J. And there's guidance in what we call manual S, which is in addition to the manual J, which kind of helps you pick the right equipment for what your manual J tells you. That gives you parameters of how big and how small you can, oversize or undersize a system based off of the BTU need for the home. But if you have a properly sized system in Houston, just a single stage, you can maintain about 50 to 60% relative humidity in a home if everything's properly sized. With an inverter-driven system, we can drive that number way down. Now, again, there are other factors. If kids are leaving doors open, or if you have a bunch of aquariums in the home, there's a lot of things that can add to the humidity in a home. But
sure,
we've had some really impressive results. But it requires it all to be correctly sized. So if you put the right size inverter system in, but the ductwork isn't properly sized, well, that inverter system isn't going to be able to perform to its maximum capacity. So it really takes a holistic approach to look at what we're trying to achieve and design the whole thing to reach that result.
And most of the systems, like in Houston, in terms of layout infrastructure, you guys are dealing in attics, correct? For the most part, in terms of where the ducts are actually located.
That's correct. Primarily attics. There are some, especially in Galveston area, there are some homes where the ducts are underneath the house in the crawl space.
Okay.
No one likes those.
No. Yeah, but you definitely don't have basements because of like flooding and and stuff like that. So but yeah, no, I figured that was the case. Are you able to, because in Colorado, sometimes what we walk into is a finished basement, so it's not easy to, let's say, just swap out ducts or run a new home run return from, let's say, a master bedroom that's not keeping up or something. And it's on the other side of the house, of course, the furthest away from the HVAC unit, which makes it difficult because that's the longest run. So of course there's no airflow. With most of the infrastructure you see to actually go in and access the ducts that need to be changed, or what are you running into? Sometimes not so much. What are the things that you normally end up doing when you're switching out duct or adding a duct? What are you able to actually retrofit?
Yeah, we wish we could in every case, but obviously in multi-story homes, there are duct runs you cannot replace, and unfortunately sometimes that requires us to let the customer know that there's nothing we can do about that specific issue unless you want to sheetrock down and kind of get into the bones of the house, which that takes it from being a very expensive project to a really, really expensive project if you have to do a lot of that. So most of the time, though, we can find workarounds. So if we had an issue where we had, let's say, too much or not enough supply on a system, we can usually engineer some sort of way to dump that air back into a common area of the home in order to allow it to properly breathe. Or returns, usually we can find a place to put another return if we need to, but it does definitely create a challenge. We had one client who their master bedroom was first floor, didn't have a really accessible attic space above it. There was no way to get duct back to the system. So in that case, we had to, basically put a little jumper in over the master door so that they could have an air return coming out of that bedroom. So there are creative solutions, but unfortunately, the initial construction of the home does limit our options in some cases.
Yeah, I was just wondering what you do, because same here, we run in, like, sometimes we'll run into an open basement on a first floor or a single story, ranch home with a basement. And for us, if it's unfinished, that's great. We can do whatever we want. It's wide open. And, it's rare that we don't get those. Those are maybe 1 out of 10. But I always just, we do a lot of times what we do is kind of the same stuff where we'll add a return. Maybe things are so choked up on return air here. And so we'll add another 8-inch or a 10-inch just to kind of open it up enough to get the actual size in there that they actually need. In terms of like when you're sizing a home, now you said you use a software for sizing. Do you also look at, you guys don't do insulation or anything to tighten up the envelope, but you do look at the envelope of the home. Is that correct?
That is correct. That's part of the process of our Manual J software. So we look at, what the insulation factors are. There's some that we just have to pull in from whatever the code requirements were when the home was built, because we're not going to drill into a wall to see what the wall cavity insulation is, right? Yeah. But yeah, we do evaluate all of that. We also evaluate things that are a little more subjective, like how loose is the home. We don't do blower door tests, to actually measure that. On retrofits, we do them on new construction and some commercial applications.
Is the blower door required? Because I know for some, for any of this stuff, for retrofit out here, in order for us to get Excel rebates, I believe they want you to run a blower door test, which, I mean, honestly, I don't think the blower door is the problem most of the time, but but it's only on new construction for you guys out there.
Yeah, and it's not even required all the time. It depends on where you are, because Texas is pretty unregulated in a lot of aspects.
I know, yeah, it is.
Yeah, it really is the Wild West. It depends on the city, though. Some municipalities require extra, than others. But yeah, like duct blasting, blower door tests, all that are not required on retrofitting at this time. Although I wouldn't be surprised if down the road it does become a requirement, because we've seen more and more focus, especially here in Texas, where we've had power grid issues, on just the massive consumption that heating and cooling, especially the cooling cycle, puts on the electric grid.
Now, when you say, are you talking about like blackouts or brownouts, or are you talking about what type of issues happen? And is it mostly in the summer?
Yeah, mostly in the summer. I mean, I think we made national news in February 2021 for our, power grid basically failing during an ice storm.
That was in all of it. That was like most of Texas, right? That was Austin,
yeah,
everywhere.
Yeah, it was really bad. Fortunately, I believe the governor has said that they've corrected a lot of those issues with the power grid. So, but during the summer, ERCOT, which is the local kind of extra government entity that manages the power grid for us, every summer they issue alerts saying, "Hey, we're going to have to do rolling brownouts, because of the demand on the power grid." So, as that kind of becomes more and more and more of an issue, as population continues to rise in Texas, people from other states that are moving here, and natural growth, and we have more and more users of energy during the summer, well, something has to give, and investing in power plants, to generate more electricity isn't always the answer. Sometimes it's as simple as, let's upgrade HVAC systems to be more efficient. What I've seen statistics that 65% of the homes' electrical usage during the summer is their cooling.
Yeah, I believe it. Once you start installing this stuff and you start realizing, you start looking at electrical panels and you realize the air conditioner is the largest circuit in the house. And it's normally, oftentimes you got a 5-ton AC. That's the same as, a 50 amp charger for a Tesla or something like that. Like, I mean, it's a lot of juice. So on that kind of note, on talking about that, one of the things, we're a big fan of inverters in terms of, for us, it's just a comfort thing. When we put in a Daikin fit, a lot of people don't, that's our, one of our go-to inverters that people love. It's a heat pump that works great in Colorado. Our climate is actually fit pretty well for heat pumps. There'll always be a few people that troll us in the comments and say, "Oh, heat pumps don't work, you need backup." And it's like, dude, it's one day out of the year. Give me, like 2 weeks ago, we had it got down to -15, right? And so it was, or -10. I mean, depending on where you were at, it was cold for 2 to 3 days. During those times, your backup heat's going to kick in. Like, we know that. There are heat pumps that work in those temperatures, but it becomes an exponential load on the house, where like the load at, 20 degrees out might be 20,000 BTUs on like a 4,000 square foot house, but at -15, that load might be 100,000 BTU. Like, it goes up a lot. So that's why we have that. But they work great here in Houston. Do you guys have a lot of heat pumps, or are people still mostly on natural gas furnace with a single stage air conditioner or 2-stage air conditioners? And talk a little bit about how an inverter kind of pulls power by comparison to a single stage system in terms of like power consumption in the summer and the brownouts issue.
Yeah, absolutely. So unfortunately, heat pumps haven't really taken off in this market, and there's no real reason that that's the case. Like no reason from the standpoint of their efficiency or effectiveness. We don't have a whole lot of straight cool with electric heat, but for the people that do have that, they definitely should be installing a heat pump. Like we see electric resistance heating bills $300-$400 a month in the wintertime, right? The heat pump down here in this climate would almost never engage emergency heat. Like you would just be basically having the same bill you have year round, right? Like just your compressor would be providing the heat for the home. Now, as far as dual fuel is concerned, that isn't a good option here because of how cheap natural gas is in Texas, right? It's just really cheap here. We have a lot of it.
And you said that is a good option?
It is not. But the coefficient of performance is not. Yeah, it's just not there. So you would end up paying more for the electricity to run the compressor than you would pay for the natural gas to heat the home. So a lot of the promotions that people have seen, the rebates, the tax credits for those types of applications, they don't even apply in this market. Like we don't even have matchups that would equal that, just because that cost efficiency isn't there. But for anyone who has straight electric, they definitely need to upgrade to a heat pump.
And what about people? Are people utilizing solar there? I know in certain markets like Phoenix, for example, you see solar on, it seems like every other house. I mean, everyone has panels. Do you find the same thing out there, or are people not keen on solar as well?
We've seen a huge uptick just anecdotally driving around. I see a lot more solar panels over the last 10 years. And I think a large part of that's due to, companies just coming in and educating homeowners on, the advantages of having solar. The other thing is, we're on the Gulf Coast and we have storms, we have hurricanes, we have power outages, and, if you have solar panels, you have an advantage.
Exactly. That's what I was thinking. Like, do people get battery backup there too? Is that, because I would think that would be huge if you're, if you're dealing with brownouts, it becomes a non-issue if you've got a power wall or something else going up. I mean, just from a practical standpoint, regardless of whether or not you're trying to go off grid or go green, because some people do you have people that are, most of the people interested in heat pumps that you talk to, is it for like environmental reasons, or do you just not get a lot of heat pump interest in general?
Just not a lot in general.
Okay.
And I'm sure there are those people. I've had clients over the years ask me about things like geothermal, ways that they can reduce their carbon footprint as much as possible. And it isn't cost efficient here. The energy in this, being one of the energy capitals of the world, basically,
sure.
Houston, it just, like, you get into the ROI or the cost of actually doing it, or if you even can, like geothermal is basically not practical in the Houston area because you can't drill. You can't drill down. So anyway, it's really been limited, and I think that's another barrier that a lot of people have had with expressing interest in heat pumps, is there's just not a lot of information down here about them. So that's one of the things we focused on. Like I said, for those clients that are straight cooling with resistance heating, they would definitely get a good ROI, the return on the investment.
And it's a no-brainer there too, because you're just swapping an air handler basically with another air handler and then putting in a heat pump, right? And so you don't really have to, even, especially on an inverter heat pump. I mean, these things cool, they're rated here to heat down to, negative temperatures. The COP drops off and the output drops off, which matters. But in Houston, what's the lowest it gets? 30, maybe like a 20s, if you get like an odd snap. Because didn't you guys just get snow recently? It was like a fluke. It was your first time. How often do you get snow? That's got to be like once every few years, right? Like,
yeah, once every few years. That was the most that we had, I think, since the 60s.
Oh my gosh,
heard different comparisons. In my house, we had 3 inches of snow, which was, I mean, for us, that's just unheard of.
You don't have plows down there.
No.
Did they just like shut down until things melted off?
Basically, and then those of us who had some experience being able to drive in those conditions, we felt comfortable doing it. But I liked it because I got on the road. I spent some winters up in the Northeast, so I had a little experience with snow and ice conditions. And I got on the road, and there was nobody else on the road, and I was like, oh, this is awesome.
I know, that's my favorite. Yeah, the only time that happens here is when we get 12 inches plus. Everyone stays home, and my wife's like, "How are you going out?" I'm like, "The roads are empty. I'll be fine. If you got four-wheel drive and fresh tires, you're in good shape." And then everyone else is staying home, so the road's nice and wide open for you. So that's cool. But yeah, but bottom line is like temperatures, they don't get really below freezing there that often, right?
No. I mean, and even when they do, it's a day or two, right? Like it's just a really strong front push through a day or two. You may get below 30 degrees, but it literally, I won't say literally. In my estimation, it's probably a total of a week out of the year that you have those kind of temperatures.
Gotcha. Yeah, it's yeah, like I was only there 1 year, obviously, like I said. I do remember we got an ice storm, kind of in the middle of January or something. But yeah, it does seem like a good climate for heat pumps. And especially just for the fact that you don't have to, because logistically, even though it might be cheaper, you're saying it's cheaper to operate a natural gas furnace for heating usually. But for someone that's doing this because they're wanting to maybe go energy independent, because like, I mean, in California, people are doing it just because their grid is so messed up that they have power outages, or rolling brownouts and blackouts, and transformers blow and things like that. And so people want to be energy independent there, just so that way they have air conditioning when no one else does. And so is there a big benefit to going down that rabbit hole of electrification, just so you're maybe energy independent and have some benefit there?
Yeah, I mean, I think that it makes a lot of sense if you were really looking at kind of being able to run in worst case scenario the day after a hurricane has come through, and there's no power and the infrastructure is all messed up. I mean, it can be weeks, right? I've had family members who have been without power for 6 weeks after a major storm. It can be a long time depending on where you're at on that power grid. So it definitely would make sense. I mean, from the standpoint of energy usage alone, right? Any inverter-driven system it's sipping energy instead of guzzling it like your single-stage systems are. Like for a lot of our customers down here, they've been buying whole home generators, right? So Generac systems. That brings another issue into the fold because the amp draw on a single-stage system is very hot, right? It can spike above 100 amps and easily, trip circuits. So we're installing a lot of soft starts. Well, if you have an inverter, that's not an issue, right? The inverter doesn't need a soft start. It'll run just fine off the generator, no problem. So if you're looking to go, energy independent, that's definitely the route to go. Like go all inverter. It minimizes how much energy you're using at a given time, stabilizes the circuit, because it's a DC motor that's being, AC is being converted to DC to run that motor. So very, very energy efficient.
So switching gears a little bit, I had, I have some questions about air quality. I know a lot of folks watching the channel have questions about air quality in the Houston, area, especially because you guys have a lot of oil and gas. So there is pollution, and people are trying to deal with, air quality in their home. What are some of the IAQ products that you guys like to use, and how effective are they in, improving the quality of air in people's homes?
Yeah, there's two products that I'm a huge fan of. One is just a media filter, right? Like stop running 1-inch filters at your return. Like if that's all you can do, that's better than nothing. But they don't really protect the system, and they're not really thin in the air. Like you need to go to a media filter that gives you 11, 13, 16 microns, whatever you're comfortable with, to really get the particulate matter out of the air. So down here in Houston, it's we know it's humid outside, right? We talked about that. Yeah. What does humidity and heat breed? All kinds of biologics, right?
Yeah, totally.
Yeah, mildews, molds, all kinds of stuff growing outside. Pollen, if you have allergies, which most people do down here because we have so many different species of vegetation. And so first of all, we want to get those things out of the air, right? And then we're going to deal with some of the other stuff that you may or may not know is there. So I worked in a different industry. I mentioned earlier, I worked in the petrochemical industry. I did environmental monitoring, so we monitored oil and gas refineries, chemical plants, to make sure that they were meeting or at least reporting if they exceeded TCEQ, Texas Commission for Environmental Quality's rules, or the Environmental Protection Agency's rules. And I was shocked when I worked in the industry about how much pollution is actually being caused by these facilities. And all that's going into the air. So most Houstonians or people in the area, they've seen on the news the air quality alerts. They get them on their phones. What they may or may not realize is why those air quality alerts are there. And it's because those chemicals in the air, whether it's ozone or whether it's SOx or NOx or any of those chemicals, they're irritants. They can cause asthma attacks. They can make it, breathing difficult for people who may have any kind of compromised lungs or immune system. And so, they provide those alerts. Well, if you're opening and closing the door of your home, any of those pollutants from outside are now coming in your home. So to address those, we have the media filter to do the particulates. What I like to put on the other side is a product called a REMI Halo. And basically it's ionized hydrogen peroxide. So it's ionized, so it'll attract and kind of clump and pull things out of the airstream. And the hydrogen peroxide portion will kill any biologics. So if it's viruses, bacteria, those sorts of things that are in the air. And I made sure that, when we were offering these products, we didn't want to just like get some snake oil, from a snake oil salesman and just start passing it along. We made sure that these products were scientifically tested and that they actually work. So if you look at this product actually, this technology was actually developed by NASA and was used in space missions to help clean the air. So that was, looking at those two solutions, you can really get that airstream as clean as possible. The only thing to do above that would be like, whole home HEPA filtration, which is, more costly and a lot more disruptive to people's lives than these products are.
Yeah, because a HEPA filter, that's technically, you're getting up into like MERV 16, right? That's essentially like it's like an N95 mask in terms of like the filtration. So it's very restrictive and more complicated. And so the two things you're really trying to address with both those is going to be like particulate matter. And you said you're running like MERV 13 typically on the media side?
Yeah, that's our preferred. Now we do have, obviously there is a concern with static pressure. So if you restrict the airflow too much, the system has to work too hard.
For clarification for viewers, that's not a 1-inch filter. That's like a 4 or a 5-inch media filter. So it's a thicker media filter, and it's a separate box that gets installed at install time. We're not talking about just slapping a 1-inch MERV 13 filter in the ceiling.
Yeah, please don't do that.
Yeah.
that may cause your system to ice up. So that's our preferred solution. And the other thing I like about that too is if you have that media filter, right? So that 4-inch filter that's sitting right at the butt of the furnace, it helps keep the blower wheel, the evaporator clean. An issue that people may not realize is that the air transit from wherever your return grill is to your system may or may not be sealed. We see a lot of homes that are, newer construction homes where return chases and other boxes are not sealed. So there is kind of the negative air pressure that occurs on the return side pulls dust and attic air, wall air into that return airstream. And all that dust and dirt is going to go collect on the wet thing that's going to hit down the road, which is the evaporator coil. So we often, when we go to a home, we see they have dirty blower wheel, impacted evaporator coil. That's one of our big upgrades for them, is put a media filter there to protect those components. But yes, that's all particulate side.
Yeah, awesome. And then on the you mentioned the REMI Halo. Now for customers that have concerns with ozone, because some of those products do produce ozone, which is technically more of an issue for people with sensitive lungs, like if you have asthma or something, that can be an irritant. Is that correct?
That's correct.
And then, the REMI, is there an alternative to that REMI that maybe doesn't produce ozone, but still has some effectiveness in removing those particles?
So the good thing is the REMI doesn't produce ozone.
It does not. Okay. So that's one of the.
We used to use another product. So there's many of these products on the market. It's
air scrubber is another one, right? And because they make an ozone and an ozone free, I believe.
Mm-hmm.
Okay.
Yeah.
So you've used those ones in the past.
Yes, yeah, we use the air scrubber, and there's nothing wrong with the product. All these products are based on the same technology. The issue for us is the longevity of the reactive cell, the UV light, the ballast. So the product that we chose to promote or to offer, we wanted to get the one that had the best lifespan, best warranty, those kind of issues. The technology itself, like I said, was developed by NASA, so there's myriad options out there.
Cool. Right on. And then as far as, switching gears kind of back to an earlier topic with dehumidification in your space, typically, are you guys installing dehumidifiers at all, or is it your frame of reference or belief that the HVAC system itself should be doing the dehumidification?
I think in most cases, a properly sized HVAC system and a properly sized and configured duct system will do enough dehumidification for the average homeowner. There are situations, though, where maybe because of the construction issue with the home, et cetera, that we will install a dehumidification system. But our preference, whenever customers call and ask about dehumidification, putting a standalone dehumidifier in their home, our first question is, let's evaluate the system and make sure it's working properly first. Again, I've seen over 12 years that properly sized HVAC systems, even single stage systems here in Houston, typically are going to land that home between 55 and 65% relative humidity. Now, the EPA guidance would be 50 to 60% would be the target window to really minimize any potential for biological growth, in closets, wall space, the areas of the home. When it's really those cases where there's maybe some condition with the home, like excessive infiltration or something, where we would say, okay, we need to get additional supplemental dehumidification in here. But I don't think it's something that I would recommend for every home.
Gotcha. Okay. No, I just like to clarify because the only time we've ever seen those, they're rarely requested here, obviously, because even in the
Yeah.
summer, I think the natural humidity outside is maybe 50, 60%. So it's really not that humid even outside. So we don't deal with it as much. So it's more in a commercial setting, indoor pools, things like that, where we're running into, because you're not going to run the AC for an indoor pool in the middle of the winter out here. And so they're normally looking at them for that purpose. Now being in Houston, obviously that's oil and gas central. You have a lot of the oil companies there. And so this is just a question. I'm just curious what you guys are running into. We have some aerospace out here, we have some oil and gas as well. So we do service a lot of engineers, and engineers, when we show up at their house, are very technical. A lot of them watch our channel. And so they're very interested in, the topics. And sometimes they'll do stuff where it's over-engineered. I'm like, bro, you don't need 4 pumps on this boiler. You just want one. Like, it's going to cause problems. I know you guys don't do any boilers in Houston, obviously, because there's no need for that, but a few weeks out of the year, right? But here we'll get a lot of those. And so what are like when you're talking to engineers out there, what are the systems that they're interested in, and what do they kind of are they asking a lot of questions about kind of, the off-grid stuff or being energy independent? Or are they interested in the heat pumps? Do they want just kind of basic systems? What are engineers kind of gravitating towards, and what questions do they have when you guys are serving them?
A lot of them ask really, really good questions about the technology and how the system does, what it's promoted as being able to do. What I've found, because my previous company prior to joining Champion and Nash, a lot of our client base were from NASA. So we had a lot of NASA engineers, a couple of astronauts.
Oh wow,
that were clients. Yeah. We did a lot of work for them, and they would always ask really good questions. And, sometimes those really good questions would end up on a disagreement. And I always told them, well, you probably know more than I do. So you want a job, because I'm always recruiting talent. No, but what I would see a lot of times is they would tend to gravitate to the higher end systems just because they understood the technology and what it could do. And a lot of them are very energy usage conscious because they understand kind of the life cycle of energy production. They understand the costs along the way, not just for themselves but also for the community. Because they deal with these types of issues all the time in their jobs, or like mechanical engineers. They're very interested in this, how we get it all to work. How does this all work? How do they overcome these different problems in designing the systems? So they tend to gravitate towards the upper end of the performance for the system. So your higher SEER, your inverter series. And they also ask really good questions. So there's always good conversations.
Right on. Yeah, no, I was, like I said, I was always curious because we get into conversations sometimes. And like I said, I had one guy, he sent me plans that he drew up himself for his HVAC. And I was like, I'm sure you're very qualified. I know you know what you're doing, but you only want one pump. You don't want four, trust me, because the only time you're using multiple pumps for boilers is when you're going to like radiant floor systems. And the reason is because the loops, like if you have a 100-foot loop versus a loop that's only 20 feet away, that difference is the water is going to be lazy. It's going to want to go, to the 20-foot zone versus, so you don't want just one pump on it. You'll have a pump going to each header for those radiant. So that's like the only time I've ever, because otherwise you're just like, you're spending money on 4 pumps that are going to go down more often and create a restriction versus just do one pump, one zone bell. But I'm always curious how, involved the engineers are in each market and what they're doing. Now, as far as brands, what brands do you guys carry? And then when people are asking for a specific brand, I mean, what's your take on brand and why do you sell, kind of what you sell and what's your opinion there?
I mean, that's a great question because there are quite a few options out there. And in the industry, my take has always been that they're kind of 4 or 5 flagship brands, so American Standard, Trane, Lennox, Carrier, then you had your mid-grade, not to talk down about any brand, because I think the most important thing from a consumer standpoint is that it's installed correctly. And I think that's kind of a universal sentiment in the industry. Like if it's installed correctly, it's going to perform, to the best of its ability. From a service and technology standpoint, we prefer Trane and Trane's ability for us to go in and really customize and dial in the system's performance to an individual home. So we're Trane comfort specialists, so we're part of their premier dealer program. We really like the attention to detail that Trane puts into all of their components, not only just for the consumer, but also for servicing and management of that system after the fact. Things like the cloud-based monitoring that we can do for the comfort leak systems that they have. So we actually know there's a problem with the system before the homeowner does in a lot of cases. We proactively manage those before they become breakdowns.
Yeah, that's awesome. I was going to ask about that. So you are dealing with cloud services, and that you guys get as far as how that works, that's like a subscription, correct? And then you have remote monitoring. Is that how it works with Trane on that particular product?
Correct. So we can remotely monitor. It'll alert us, if there's any hiccups, any issues with the system. We can pull performance reports. So, if someone's like, what, it feels like it's running longer than it used to, or any kind of concern that the customer may have, we can actually pull the empirical data from the system itself and see what the run times were, what the humidity level was at the time, just that whole performance report that we can get out of it. In addition, I think the biggest benefit though for homeowners is that kind of proactive monitoring that it does, where if the system's experiencing an issue, it's going to alert us, and hopefully it alerts us and we are able to correct it before they experience a breakdown. That's kind of the goal of that.
Gotcha. Yeah, no, it's definitely a perk to be able to know what you're walking into before you show up, obviously. So I'm sure your technicians like that. So I'm always curious if people are starting to use cloud services, because we sell Daikin and they have a cloud product as well, and we've started to integrate that a little bit on some of the systems and register the products so we can see things remotely, which I think is cool. I think 10 years from now, HVAC is going to be kind of wild. It'll almost be like, who knows? We'll see what happens with AI and everything. But I think we're going to have, it's going to be really interesting what happens. It's definitely, the HVAC industry as a whole is definitely a little bit more slow moving than everything else. It's like once something's been tested, they're not like trying to push AI into every system because people don't care about fancy. They care about reliable when it comes to HVAC. So they're like, let's make sure it's reliable before we put in the fancy. Right. And so, but no, I think that's cool, and it's obviously nice to hey guys, we've got another whatever air code. Go make sure you clean the condenser, right, or make sure you check the filter. In terms of like annual maintenance and what the requirements are out there because the systems run so long, how long is your actual cooling season? It's like 9 months, or when do systems first kick on?
I think officially they would say it's 9 months. I think it's more like 11 and a half.
Okay. Gotcha.
You can, I mean, just kind of for instance, like we had that snowstorm, right? So
Yeah.
for 2 days it was below freezing. By that weekend we were mid 70s. So in terms of like most people in their homes, they're going to cycle their air conditioner throughout the winter. It's just going to flip back and forth between heating and cooling, and then we're going to get to spring, March, April, May, and it's just 100% cooling degree days out there. So I just don't think there's ever a season where we're not engaging the cooling modes on our system. So I think it's so important. Like I know that a lot of people think of HVAC systems as being just another appliance in their home. And what they don't necessarily think about is, number one, the amount of load that's put on these systems. I mean, they run tremendous number of hours, throughout the year. Two is like the custom engineering you have to do to install one, especially a retrofit. It's basically like I've used the analogy with customers before that, if I was buying a Ford pickup, I can go to any dealership and I get the same truck. It was built on an assembly line somewhere, same quality control. It's delivered to all these different dealerships. But if the dealership got the pieces from Ford and put it together,
Yeah.
and then sold it to you, I would really care about which dealership I chose. And so that's one of the, I think that's one of the things that I try to help consumers really understand, is that these are complicated pieces of equipment that have to be custom built basically in your home. And depending on the condition of your home, it can be way more custom, depending on how tight the three-dimensional spaces we're working in. But
Absolutely. And then as far as some of the best practices that you obviously do system sizing, so you do the load calcs, and that's critical. You look at the ductwork. What are some of the other best practices, or are there any that are like Houston specific in terms of like hurricanes and hurricane codes? I know there's a lot that goes into that. I've always wondered, like, how does I've never been in a hurricane, and so I've always wondered, how does an HVAC survive that? Because you get 100-mile-plus-hour winds, right? And so are things that, staked to the ground? Are they secured to the wall? What do you guys do as far as that's concerned?
Yeah, so we do have pretty stringent wind code requirements, right? So I think, it's like category 3, I think it's like 135 mile an hour winds or something that everything has to be, built to. For us, that basically is putting in a hurricane slab. So, these are 90 plus pound slabs that we put down. That's the condenser pad that we set the condenser on, and then we actually strap the condenser down to that pad. I've never seen a condenser blow away, but if you've got strong enough winds, it could probably happen.
And you don't do as much of the side discharge, right? You do more of the trash can style, the big like box condensers versus a like the little slim ones.
Yeah, historically, yes. More and more we're seeing offerings, from Train, from Lennox. The Daikin Fit was kind of the first, it was like a VRF that they brought over to residential and said, here you go, you can use this. Now we're starting to see them, like all the manufacturers starting to come out with them. And it makes a lot of sense, because if you're dealing with townhomes, condos, like limited access areas, it's much easier to install. It's much easier to fit it in around the home's footprint.
On the clearance, you only need like 3 inches, 4 inches on the back, which is just wonderful.
Yeah.
Versus some of the manuals, when you read them, you're like, okay, this thing's supposed to have 12 inches on 3 sides. I don't, I don't know how this is gonna go, because sometimes you see those back gates, the gated in section. You're like, dude, there's like 3 inches of space. But no, I was curious, just also too, because of like hurricane code, that to me looks like a giant, sail, versus the box is a little bit harder to move. So I was just wondering, because we, even out here, we get strong winds, every once in a while, but we'll strap them down or put them or brace them to the wall, if they're, depending on where they're located, for that reason, because they can blow or blow over. So, but
well, that's one of the really unique things about them, is you can just mount them to the home. So that really helps with the footprint of the system and locating it.
Sure. Yeah, no, absolutely. And then one question for people in the, talking about longevity in systems in the Houston market. When it comes to repairing versus, replacing systems, right? People always, often ask me, like at least my family will call me sometimes and be like, "Hey, I got a quote for replacement, blah, blah, blah. Hey, I haven't talked to them in years and they call me from wherever." And depending on the market, right, I'll have a different answer because, my dad lives in Southern California, and I mean, I think Southern California, and he lives by the coast, right? So, I mean, it's, 80s in the summer. He swears it gets hot. I'm like, that is not hot. I've been there in the summer, but it's, they run the AC a month out of the year, top sometimes 2 weeks. They'll be like, "Oh, it's brutal," and then it's over because you've got that Mediterranean climate. And then I think right now it's like 50s and 60s. So it's like they don't need the heat really. A system could last 30 years, right? 40 years in Southern California, depending if you're really close to the ocean. But then the salt, eats away at it. But then when it goes out, because it's so nice out, you'll be like, "Oh, the AC's out. Oh, it's going to take 2 weeks to get someone out here. Forget it." And I'll just, and then the year goes by. Obviously that's not happening in Houston. And because the systems are running for, you said 11 months, 9 months out of the year for cooling, maybe 10 months even. What can people expect as far as like life expectancy and when, in that repair versus replace equation, if someone was leaning towards, because there's been the refrigerant phase out, and so there's new refrigerants coming into, and so for people that are kind of on the fence, what is actual life expectancy down there for the systems you guys are replacing?
Well, that's one of the bad news or bad pieces of news that I have.
Yeah.
The average lifespan of systems in the Houston market is 10 to 12 years,
Yeah.
and that's just because of the extended run times, and they're running so much. I should have had it prepared for this, but we did a calculation of how many hours the systems ran, in a 365-day year when we were having this discussion in our shop, and it was a lot. It was a whole lot. So we basically equated like 10 years to, like 130 or 140,000 miles on a car, based off the run times. What we see though, even as you get closer to the coast, you mentioned the salt being an issue, is like Galveston Island, which is just off the coast here by Houston. You may only get 8 years because of the corrosion from the salt in the air. And so we do have communities in the greater Houston area that are on brackish water. So that's why it's kind of that 10 to 12 year range. North Houston, maybe 12. Closer you get to the coast, less and less. So we always want to make sure our clients are aware, because most people don't think about what happens when their air conditioner dies or needs to be replaced. Like they don't budget for it, they don't have a plan for it, and so it's a surprise. And a lot of clients, a lot of people that engage us, they don't even do maintenance on their systems. It's just an afterthought for most people.
Really, I would think so. Even with, they're not good about filter changes and things like that, because that's kind
No,
of
yeah,
uh,
yeah, it's sad sometimes, the filters that we see.
yeah. I know it's terrible. Well, I feel like new homeowners fall into that trap a lot because they just don't, they're like, "What filter?" I don't think my system has a filter. I love when people say that when I'm talking to them on the phone. I'm like, "Wow, this is going to be an interesting service call." When I was when I was still in the field running a lot of calls, I would be like, "Oh, brother," and you pull it out, it looks like a dead cat. But
Yeah,
called
yeah,
the Ductwork. You're like, "Oh, this is gross." And
yeah.
they feel embarrassed, but you're like, "Don't worry, this is the third one I pulled out today. You're not alone." Okay, so people aren't actually that good about like maintenance. If you're putting in a media filter, are you having to change that twice a year out there, or can you get by with once a year, or what do people do with those, like the 4 or 5 inch media
Yeah.
filters?
We recommend you change it at least once a year. What we don't just go off of a time span. What we like to do is take the pressure drop across the media filter to tell us how dirty that media filter actually is. So for us, when we do maintenance, that's what we do. If I had a customer who they weren't going to do maintenance with us, I would say, well, at least change it every 6 months.
Gotcha.
I think the manufacturer says you can go up to a year, but it really depends on pets in the home, all
Sure.
kinds of factors that go into that.
Yeah, and what is the pressure or the static pressure you're looking for when a filter's toast? Is it because are you sizing for 1/2 inch water column, or when you're doing like your duct does, I mean, I know
Yes.
you're not doing duct design so much in, retrofit, but is that kind of what your target is? And then if it gets much above that, you kind of replace the filter?
That's correct. Yeah, we try to target the total external static of, half an inch water column. In a perfect world, everything would be designed to that, right?
I
But
know, yeah.
this isn't a perfect world. So we do measure the drop across there. Right now, the exact number escapes me of what we have in our condition. We have really fancy forms that help the technicians. So it'll basically take that. They'll enter the reading and it'll tell them like pass fail basically. And that's just a conversation. Then we pull it out, look at it, have a conversation with the customer, say, hey, do you have a filter? If they do, we put it in. If not, hey, you need to get one, put it in.
Yeah, right on. And with when it comes to customers also like replacing equipment, at least this year in particular, if they're kind of due for replacement. I know one of the questions I get asked the most, whether it's in the comments or just emails sometimes or whatever, people will say, hey, I'm leaning towards an R4, I have an R22 system now. I'm leaning towards 410A. You probably don't see any R22 systems, or very few, just because they haven't lasted that long.
Yeah, very few.
But out here, we do have a few people that really, will run the system into the ground or don't use their AC, that often. I feel like Colorado or mountain people. So summer hits and they like leave the whole day anyways. They get home at 9 o'clock. So maybe they don't use their AC that much. But when you're dealing, if someone's on the fence and they're like worried about, oh, I want a system that's R410A, or because it's tried and true, even though it's going to be phased out. Because in the phase out is we're still gonna have access to 410A obviously for a couple of decades, and so it's not like, so if someone bought a 410, because are most of the systems you're installing today, are they 410A or are they now the R454B? Have you guys made the switch to most the newer stuff?
Yes, we made the switch to 454B,
Okay,
and a lot of that's driven by availability.
sure, yeah. It's
There's
not
not a
like
whole
it's
lot
not a
of stock,
choice. Yeah,
right?
yeah, no, that's what I meant. I just didn't know, because some of the stuff out here, we're still waiting on a lot of the inverter R32 stuff. I
Mm-hmm.
think is, as they were saying, Q1 for some of the products, and so I haven't been up to snuff on weather, but we've been installing R32 single and two stage stuff for a while, or since last year. But um, so yeah, so if someone was, what are your thoughts on someone that's like concerned about being a guinea pig with the new refrigerant or something like that, versus because you can't get 410A systems anymore basically in your market, probably, if that's the case. Is that correct?
Yeah, it's very hit or miss. Yeah, I've had customers that not so much worried about the reliability of the 454, and I'll touch on that. But a lot of things, or a lot of the questions they've had a bit about the safety, right? Because much ado has been made about the fact that it's this A2L, and it's
Flammable.
flammable, and yeah, it's gonna
Yeah,
blow your house
flammable.
up. Yeah. And I was talking with a very sweet lady the other day about it, and I told her like the chance of it actually reaching concentrations to ignite is very, very, very small. And there are sensors on the systems now, so if they detect a refrigerant leak, there was a process they do to basically evacuate any potential buildup of refrigerant to prevent any kind of ignition situation. I said, but ultimately, at the end of the day, all refrigerants are flammable. It just depends on what pressure they're at, what their temperature is. Um, Even 410A, if you could put it in a scenario that it could be flammable. And the other aspect is like if you look at the actual kind of like burn rate of something like 454, it's less, or it was less than 10 centimeters per second that it would burn. So it would be a very slow propagating flame. It's not an explosive situation, but they still went ahead and put the sensors and everything in place to make sure that scenario where the concentrations could reach a flammable point didn't happen in residential applications. Now, as far as like the reliability portion, that's something that we all worry about every time manufacturers come out with a new system, right? Like
Yeah.
it's just it
If
hasn't
anyone
been
wants it
fully tested.
reliable, yeah, if anyone wants it reliable, it's you and me, right? More than the homeowner.
Yeah. Yes, I mean as horrible and disruptive as it is for the homeowner,
Yeah.
it's way worse for us in the sense that we have thousands of clients, and if we're promoting a product and we put it in their home, we own it. Like there's a
Yeah.
responsibility that we have to maintain it, and so yes, we're very concerned about reliability. The good news is if you look at the pressure and temperatures that 454B runs at, it's very similar to 410. Like the performance envelope for the refrigerants are very similar. There weren't any radical changes that were made to system designs. There was, compressor change, TXV change, some little changes here and there, but overall, I think it's going to be pretty reliable because it's based off of very reliable technology from 410. That era. We saw a huge problem when we switched from 22 to 410. And a lot of that had to do with evaporator coils, because we're running higher pressures. And I don't foresee any kind of situation like that with this changeover.
And also, just worth noting, the A2L classification, there has to be a constant flame applied to it, right? It's not something that can, it's not like it'll catch on fire and burn like propane. Like you need to you have to hold an ignition source to it, like a lighter. And then when that's removed, it'll stop burning. So it's not, I think the whole flammability thing was blown out of proportion. But a lot of people, that were worried about that. It's and R32 is like 50%, 410A is 50% R32, right, in the blend. Right. And then in 454, it has some other, so it's like we're already using, there's a lot of similarities. So I don't think shouldn't be the concern as much, but people are worried about reliability. But in your experience so far, you haven't had any noticeable differences, right? I mean, it's like the same, they run at the same pressures basically. Yeah, so it's pretty,
it's very similar. I mean, just like if you walked up on it and you didn't know which one it was, easily assume it was running 410 just based off the temperature readings and overall performance of it. So that's why I'm not as concerned this time around. I do think some of the overblown elements of this is because, insider politics in the industry with the people who make refrigerants and
I know.
One.
I know. No, when I made a video about, the refrigerants and the whole thing, my whole pitch there was like, I just tell people, the whole reason they're doing a phase out. And it's like people are tired of BS, right? They want the truth. And it's like, it's planned obsolescence, right? It's like iPhone comes out with a new camera and it's like, oh, you've got 3 cameras now. My phone will probably be a wall of cameras within 5 years. By the time I get the iPhone 54 and I've got a beer down to here, it'll be just like all cameras. And then it just sees 360. But it's like, oh, the new one. But, because it's like people, that was my take on it. And there are obviously there's benefits with like increases in efficiency. Like there better be, like, why are you switching it if there's no benefit? But I do think that, it's kind of one of those things that, if you still want to stick with 410A, they do have like if you're doing a repair and that's really what you want to do, like they have drop-in replacements, right? And so if you want to spend the dough on if you're selling the house and you're like, I don't want to deal with it right now, I just fix it and it needs, it's empty on refrigerant, you got to replace a coil or something and you want to stick with 410 because you can still get 410 coils probably. I'm assuming it's those are still available. And so because I know we have to, warranty the equipment we just finished installing, so we'll be able to get those for a while. But yeah, no, it's always interesting when they, the contractors are the one. I feel like the manufacturers push the stuff out, and then the contractors actually have to figure out, how to install it and what actually works, and then we report back, and then they, refine it a little bit. But so far, it seems like it's been pretty smooth. We haven't had, I know on our side, we haven't had any issues with, that are like refrigerant specific with R32 causing a whole bunch of problems or issues with boards that are out of the ordinary. It's just, it's like you said, one extra sensor and, which is only an issue if you get a leak. And then, but besides that, it's really not that big of a deal. Seth, thanks for coming on the show. I'm, sure everyone watching found this super helpful. If someone's in the Houston area and they want to get in touch with you, where can they find you?
Yeah, the easiest way to find us is just go to Google and look at Champion and Nash. And, we're quickly growing into one of the premier providers here in Houston, and we'd be very happy to come serve.
Right on. Sounds good. And we'll make sure to link that in the description for you guys. So hopefully you found this content helpful. And if you did, please make sure you smash that like button for the algorithm and consider subscribing to the channel. And we will catch you on the next episode.